Hello, welcome back to LIVENODING. So we're gonna continue from where we left off last time. Last time we have this kind of setup using grease pencil and spread chalk, where we can let the user draw all kind of strokes, and then spread chalk will convert it into some kind of like a line that has a z depth. So when you look at it from one angle, they don't overlap. So yeah, from this setup, we can further work on it, but using animation nodes. So this is what we have. We can just actually just hide it, and this is the actual line and points, and we're gonna use these points inside animation nodes. So it's as easy as using a viewer vmesh, pipe it in there, and then merge it into a single object. So you have a single object, which is just a collection of these points. So I'll save this as animation nodes, grease pencil, procedural drawing. And so we have the points. We can hide the points in spread chalk. So we have the real points. Go to animation nodes and grab the point using mesh data. Mesh data from objects, just get our points here, our objects, and that's pretty much it. Basically, just use world space, use modifier if you like, and we can separate mesh data and just get the vertex locations. For the vertex locations, we can use object instancer. So animation nodes doesn't have many mesh generator, but we can use spread chalk just to create a circle, for example, and just create a circle. So that's a circle, and we can use that circle inside animation nodes. Just grab it, and we will instance the circle over the points. This is the point position. We want to get the total number of the points. Just plug that in. We get this get length, and this is the actual objects, and we want to place the objects where the position of the circle is. So there you go. We have circles on top of every point that's coming from grease pencil and processed by spread chalk. Okay, anyway, we have our circles. Good. For the dots itself, we can simply hide it or make them not selectable. So this is the points. Make them not selectable, not renderable. Okay, with this, with these objects, the circle, we can kind of play around with it. We can perhaps scale it or rotate it. It's totally up to you. You can also wiggle it. Let's try doing that. So scale, wiggle, I'll try offset vector, scale. Scale is always slightly tricky one, but you can plug in like a random scale for this guy. So random vector, first of all, and the number of this guy should match the number of points. So let's try that first. So this is a random scale. Sometimes you don't want it to be too random, but in this case, it doesn't matter too much. You can actually animate this if you like. Let's try, just use a matcap so we can see a bit clearer. So it's a bit abstract, but it's okay. And with this guy, you can animate it like this, pretty random, or you can wiggle it. The wiggle vector actually probably can be animated as well. This guy, let's try it. So this is vector wiggle for the scale, and yeah, apparently you can animate it that way as well. It's gonna be like a flipping and stuff, but it doesn't matter, In this case, doesn't matter. If you render it as like a shaded material, even if it's flip, it probably doesn't matter too much. Sometimes maybe you don't want it to be too random like this. Maybe we can do something about it. Maybe instead of using vector wiggle, we use a float wiggle or number wiggle. And the number wiggle can, okay, the number wiggle doesn't actually have the multiple value, unfortunately. So back to vector wiggle, or let's try using offset vector. So offset vector, plug this guy in. We want to have random vector. Let's try using a 2 random vector just to make things a little bit more complex. It's not too bad. This is like the original vector. This is the random vector, and we need to turn on this guy. So this is the original. This is the one after. Plug this guy into the scale. Fall off. Okay, we can now animate it this way. Just wiggle the fall off. Wiggle the fall off is always kind of like a strange terminology, but really wiggle fall off is just like a noise you add to the fall off. So it goes like between 0 and 1 in random fashion. So I'm still learning this as well. So now it's kind of wiggling between this random vector and the second random vector. So this is kind of like the interpolations in between. And we can also turn on the interpolation. Where is it? Fall off interpolation construct. What is construct? Evaluate or mix. Maybe interpolate fall off this way. Just use the back. So now this guy is a bit more interesting. There is some kind of interpolations happening. Okay, so now it's a little bit more random. Yeah, it's a little bit more abstract, but try doing this using different methods. I think this is a little bit more fun. And you can also do a little bit more. Let's say instead of just scale, you can use the rotations and just plug this vector into that guy. Oh, apparently it doesn't quite work because rotations need directions to rotations. And maybe this guy will work. Yeah, apparently this works. So a lot of strings connection here. But you see, the animation is really fast. And if you go back to SphereChalk and just increase the sampling, maybe you get a more interesting result. See, everything is procedural. Go back to animation nodes and look at it from the top view. You have this quite abstract design, very unusual, and you can always change the grease pencil stroke and you get a different result. Okay, so yeah, that's I guess kind of pretty much it. You can always replace the instance. Currently we are just using a circle, but remember animation nodes instancing is really fast. So if you change this with a monkey head or a torus or a cone, whatever, let's say you're using a torus, just replacing the instance, you're gonna get a different result like that. Yeah, just make a random doodle. It's gonna update. So yeah, it's a bit abstract, I know, but I guess this might be useful for you at some point. Basically, like grease pencil, is like a form of data that you can give a user, like a user can doodle whatever, and that's kind of a stroke data. You can process it further using SpreadChalk, and then you can bring it to animation nodes to animate every single sampling of the points of the grease pencil. So that's the idea anyway. But yeah, it's getting too abstract now. Yeah, but hopefully it is useful for you, and I'll see you in the next video. Thank you. Bye.